Okay, so some other things we can do with radians. Today we're going to look at periodic functions. Those are your sine and cos curves. And we're going to look at graphs of those things. You might remember some things like amplitude and period and phase shift. So some basics, reminders. Okay, we have our standard form for a function that's periodic. Okay, and we're going to transform that according to our a or k or d or c, and same way transformations have always worked. And we have to apply those transformations to sine and cos. Okay. Our parent functions that we're familiar with are the 0, 90, 180, 270, 360. That's normal. And for a sine curve, 0, 1, 0, negative 1, 0. But we're going to get rid of the degree part and do it in radians now. So you have basically a new table to memorize. Okay. So we're going to go from 0 to pi over 2, to pi, to 3 pi over 2, to 2 pi. If you think about that on rotational stuff, 0, pi over 2, pi, 3 pi over 2, and back to pi again. You might recall that these numbers that we actually graph come from the rotational trigonometry. Cos, same idea. We're going to use our radians, just a different set of y values. They start off in a phase shift from the sine curve. So we start at the 1 and go down to the negative 0, negative 1, and then back up to the 1. Okay, let's go through some reminders. Our period, that's the length, the horizontal length of one curve. Normally, it used to be 360 over k. We're going to change that now to 2 pi over k. K is your horizontal stretch or compress. Your amplitude is A, same as before. Our equation of our central axis is C, same as before. Our phase shift left to right, that's your D value, the part inside the bracket. So remember to change your sign. And your domain is always all real numbers because these go on infinitely, unless it asks for one cycle, in which case we'll have to say where it starts and where it ends. And our range can always be found with our central axis, which is our average, minus the amp, and the central axis plus the amplitude, and that will be where your values fall between. So some examples of some stuff from before. For each of the following, determine the amplitude and period. So nothing new here except for my amplitude is A. Nothing new here except for my period is going to be 2 pi over k. K is the number in front of x. So there is no number in front of x, so 2 pi over 1, or in other words, 2 pi. Okay, every cycle is completed. Sorry, it takes 2 pi to complete every cycle. If I try the next one, my amplitude, my number up front, my a value is a 1. My period, well, the period is affected by this. So my period equals 2 pi over k. K is 2/3. So 2 pi divided by 2/3, which you can use your calculator if you want to, or think about what does that mean to divide fractions. It means we flip and multiply. The 2's can cancel top and bottom. So the period for this one is actually 3 pi. Okay, there's nothing new here. We haven't changed anything except for 360 has become 2 pi. Same stuff that we've done before. Nothing new. Okay, let's look at some graphs. So I want to state the transformations, determine the range and domain, state our big properties, and then we're going to sketch the function. So this is the big ideas. The only difference, remember, is that we're changing degrees to radians. Everything else stays the same. So let's make a list A, K, D, and C of the different things we're going to do. So transformations. So A is a vertical stretch by a factor of 2. Something outside the bracket, so it's a y thing. It does just what it looks like. It multiplies, so it stretches it. Okay, the k is our 3. It's inside the bracket. It does an x thing. It does the opposites. So it's a horizontal compress by a factor of 3. Okay, the pi over 2 inside the bracket is an x thing. It's our d value. It says minus, so we do the opposite, which is plus, which moves it to the right. Pi over 2, that's your phase shift. And the c value, the thing at the end there, it's outside the brackets. It's a y thing, up 1. Okay, the exact same stretches and compresses we did every other function. Whether it was a polynomial, whether it was the absolute ones, all the ones from last year, same things. Okay, some more things. We want to find our range. Okay, our range can be found by figuring out what's average and how far we've gone from average. So average is our central axis. That's 1. but our amplitude is 2. So we go 2 higher than that and 2 lower than that. So if I take my central axis, that's 1, and I subtract the amplitude, I get my lowest value ever reached. And if I take the central axis and I add the amplitude, I get the highest value ever reached. There's my range. Okay, our domain. Now careful here, it says domain for a cycle. Okay, so what I need to know is I need to know where my first starting point is. My first starting point is supposed to be at 0, except for we've moved it right pi over 2. Okay, how long does it take to complete one cycle? Well, we said that 3 will give us our period, or sorry, will help to combine to get our period. 2 pi over k, 2 pi over 3. Okay, so to figure out the other part of the domain, I need to take where I started, which is pi over 2, and add 2 pi over 3. Okay, starting the initial value, initial, plus the period. You can use your fraction button in your calculator, so 1/2 plus 2/3, or if you want to make a common denominator, this is 3 pi over 6 and 4 pi over 6, or in other words, 7 pi over 6. Here's my domain. We're asked to state the amplitude, the period, and the equation of the axis. So I've kind of shown the period up here already. Help me get my domain. The amplitude, we know it's our A value. We kind of already did that when we talked about a vertical stretch. And the central axis, we kind of already talked about that when we talked about the C value. We just got to remember to put it in the right format. It's an equation, y equals. And the last thing we want us to do is to sketch this function. So to sketch something, we're going to use a parent function in a table. And I'm going to put it on our graph. So the standard table for a cos curve, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And cos starts at 1, goes down the bottom, and then back up again. And then we do our transformations. What do we need to do? We can just stretch it by 2 and then move up 1. So double the y's and add 1. Compress by 3 and then right pi over 2. So x over 3 and then add pi over 2. And we get ourselves a new table. Okay. If I divide 0 by 3 and then add pi over 2, we get our starting point. Okay. Pi over 2 divided by 3 gives me pi over 6. I'll just put it off to the side just to show you guys. So we're going to do pi over 2 divided by 3 plus pi over 2. This is going to give me pi over 6 for the first part, plus pi over 2, which if I think about a common denominator, times it by 3 is actually that. So 4 pi over 6. Okay. I'm going to do the same thing with the next one, except for I'm going to use pi this time. So I'm going to do pi plus pi over 2. Again, this is like saying 2 pi over 2, so I get 3 pi over 2. Okay. Now, before I keep going for the rest of them, I'm going to show you a little trick, a little pattern idea. Okay. If you stop and think about these fractions can all be written with a common denominator. Pi over 2 is actually the same thing as 3 pi over 6. This is 4 pi over 6. Here's where I catch my mistake. This one back here was supposed to be pi divided by 3. So I messed one up here. Sorry, guys. Pi over 3 plus pi over 2 is 2 pi over 3 and 3 pi over 3. So 5 pi over 6. And you'll see how I know I caught my mistake in just a second here. Okay. If you notice, I've got 3 pi over 6, 4 pi over 6, 5 pi over 6. The next one's going to be 6 pi over 6, and then 7 pi over 6. And your x value should always follow a pattern. Okay. Often if you use your calculator, you're going to reduce them. Okay, so like 6 pi over 6 is just pi, 3 pi over 6 is just pi over 2. But if you write them with a common denominator, it actually is easier to figure out the table in the first place. Okay, we do our y's next. We'll get 3 for the first one. We'll get 1. We'll get -1. We'll get 1 again, and 3 again. And now we can graph some stuff. Okay, pi over 2, and 3 is right there. 4 pi over 6. So where does 4 pi over 6? I got to think about that as a reduced fraction. That's 2/3. So if I were to break this graph into thirds, 4 pi over 6 is 2/3 and 1. Okay, 5 pi over 6. Again, I got to break into thirds, and then each third I got to break into halves to make sixes. 1, 2, 3. Sorry, change that line there. Okay, so we need to do a 6. Oops, a little bit to the side again. A 6. We have the next 6, the next 6, a 6, and the next 6. This line here is just messing me up a little bit. Move it over to where it should be a third. Okay, there's my 5, 6. Okay, so 5 pi over 6. Oh, we need to put some more 6 in here. There's a 6 right there, 6 right there. So we have 1, 2, 3, 4, 5, 6. 6 equals 6. Okay, 5, 6, and -1 would be about there. We need pi and +1, which is right there. And 7 pi over 6 and 3, which is right there. This first dot's off to the left a little bit too much. Okay, graph looks like that. There's one cycle. Okay, I'm going to try another one. Let's take some practice here. Our only change here again is radians. Okay. So transformations. We're going to do transformations, and if we need to, deal period and amplitude at the same time. So make a list again. Okay. A is our vertical compression by a factor of 1/2. Our K, it's a third, which actually means it's going to stretch by a factor of 3. Our D is going to move it left, opposite sign, pi over 6. And our C is going to move it down 2. Okay, my range and my domain kind of deal with our amplitude and our period and all that kind of stuff, so I might as well write those down too. Our amplitude is A, which is 1/2. Our period is 2 pi over K, which is 1/3. It's going to get 3 times as long, so 6 pi. And our central axis has the equation y equals -2. Okay, so what's normal? Normal is -2 in this case. And from normal, we have to go down 1/2, so -2.5, and then up 1/2, -1.5. So this is our CA plus amp and CA minus amp. Okay, domain, we're starting at, we move to the left, pi over 6. So left pi over 6, up to, I got to take my pi over 6 and I have to add the period. So -pi over 6 plus 6 pi's. Okay, fractions, so pi over 6 plus 36 pi over 6 will give me 35 pi over 6. Okay. So we did our transformations. We got our amplitude, period, central axis, range, and domain. Time to draw. So I'll take our graph and move it down below. What do I want to draw? I want to draw a cosine. There is a sine curve this time. Okay. So what do I start with? 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine curves start at 0 and go up and then back down. And we are going to transform. What are we doing? Well, we said we're going to compress it and move it down vertically. And then we said we're going to stretch it by 3 and move it to the left. Pi over 6, I think is what our numbers were, right? Pi over 6? Yes. Okay, so new table. Let's get the y's out of the way first. Negative 2, half of 1 is a half, minus 2 is negative 1.5, and then negative 2 again, and then negative 2.5, and then negative 2 again. And let's deal with the x's. If I triple it and then subtract pi over 6, that's a nice easy starting point. If I triple the next one, 3 times pi over 2 minus pi over 6. I get 3 pi over 2 minus pi over 6. Common denominator of 6 will give me 9 pi minus 1 pi, which is 8 pi over 6. Okay, what's my pattern? It looks like I've gone up 9 pi's. Now, if you want to test it, try the next one and see what happens. So I'm going to times it by pi, which is 3 pi over 1. Okay, common denominator again gives me 18 pi minus pi over 6, which is 17 pi over 6. Hey, I went up by 9 pi again. So I know what the next one's going to be. It's going to be 26 pi over 6 and 35 pi over 6, which matches our domain. Where the table ends is where your domain should end for one cycle. Now, those aren't necessarily nice numbers to graph. Maybe you want to reduce some of them if you can. Like 8 pi over 6 is actually 4 pi over 3. 26 over 6, that'd be 13 pi over 3. I don't know if those are necessarily easier, but you know where they are. And we can graph this. Okay, let's give it a try. What do we know for sure? Negative pi over 6. Okay, we have to break this into thirds. So 1/3, 2/3, and then into 6. That's a 6, that's a 6, that's a 6. So negative pi over 6 and negative 2 is about there. Okay, the next one, again, I need thirds. So break into thirds. And I've got 4/3 and negative 1.5. Sorry, that's not 4/3. It's 1/3. Right? 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. So 4/3 and negative 1.5 is about there. All right, 17 pi over 6. Ooh, that's a big one, right? That's almost 18 pi over 6. And 18 pi would be like 3 pi's, right? So if we think about our graph the way we have this, that's 2 pi, this is 3 pi. We're stopping just short of that at 18 pi over 6. We put our thirds back in. There's a third, there's a third, there's a sixth, there's a sixth. We need to be at 0 and 18 pi. Now, I can't fit the rest of the graph in mine. Hopefully you guys can. But it's going to look something like that. Okay. It just doesn't fit on mine. If that is the case, we probably should just pick a different scale, but that's the scale I was given to work with. Okay, let's try one more thing today. I want to be able to sketch this function over the domain of negative 2 pi to positive 2 pi. So rather than just being one cycle this time, we are going to make multiple cycles to complete a domain. So sketch this number obvious one thing.